Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick until the end of the video, where I have two bonus problems that are similar to this one, which you guys can try to solve. So I have 2 to the power of 16 minus 16. Now 16 here, this is the same thing as 8 times 2. So now I have 2 to the power of 8 times 2 minus 16. Now 8 times 2, well, first off, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 8 times 2, that's going to equal 2 to the power of 8 to the power of 2 minus 16, I can rewrite as 4 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So 2 to the power of 8 squared minus 4 squared. In this case, a is equal to 2 to the power of 8 and b is equal to 4. So now I have 2 to the power of 8 plus 4 times 2 to the power of 8 minus 4. Now 2 to the power of 8, well, 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, 2 to the power of 3 is equal to 8. So as you can see, this just doubles. 2 to the power of 4 is double of 8, 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. 2 to the power of 7 is double of 64, which is 128. And finally, 2 to the power of 8, this is double of 128, which is 256. So now I have 256 plus 4 times 256 minus 4. Now 256 plus 4, that's going to be 260, times 256 minus 4, that's going to be 252. So now I have 260 times 252. Now I'm going to rewrite this as 260 we can rewrite as 250 plus 1, and 252 we can rewrite as 250 plus 2. Or sorry, 250 we can rewrite as 250 plus 10, and 252 we can rewrite as 250 plus 2. So now we have 250 plus 10 times 250 plus 2. So I'm going to first start by distributing the 250. So now this is equal to 250 times 250 plus 250 times 2. Now I can distribute the 10. So I have plus 10 times 250 plus 10 times 2. Now this is equal to 250 times 250, well, 25 times 25 is 625, so then we just add in these two extra zeros. Now 250 times 2 is 500. 70 times 250, or sorry, 10 times 250, that's 2500. And finally, 10 times 2 is 20. So now we simply have to add all of these up. So 62,500 plus 500 is 63,000. Plus 2,500 plus 20 is 2,520, and now this is equal to 65,520. So this is my answer. Alright, so I have 2 to the power of 20 minus 9. Now first off, 2 to the power of 20 we can rewrite as 2 to the power of 10 times 2, because 20 is equal to 10 times 2. Now I have minus 9. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2, that's going to equal 2 to the power of 10 to the power of 2. Now I have this minus 9, we can rewrite as 3 squared. And now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10, and b is equal to 3. So now I have 2 to the power of 10 plus 3 times 2 to the power of 10 minus 3. Now 2 to the power of 10, well, 2 to the power of 1, this is equal to 2, and 2 to the power of 5, this is equal to 32. So 2 to the power of 6, this is equal to double of 32, 64. 2 to the power of 7, this is equal to double of 64, which is 128. 2 to the power of 8, double of 128, 256. 2 to the power of 9, double of 256, which is 512. Finally, 2 to the power of 10, which is double of 512, which is 1024. So now I have 1024 plus 3 times 1024 minus 3. Now 1024 plus 3 is 1027, times 1024 minus 3 is 1021. Now 1027 we can rewrite as 1000 plus 27, and 1021 we can rewrite as 1000 plus 21. So now I have 1000 plus 27 times 1000 plus 21, and now we can solve this by distributing. I'll first distribute the 1000, so I have 1000 times 1000 plus 21 times 1000, plus now if I distribute the 27 times 1000 plus 27 times 21. Now 1000 times 1000 is going to be 1 million, so I have 1 million, plus 21 times 1000 is 21,000, plus 27 times 1000 is 27,000, plus finally 27 times 21 is 567. Now if I add all these up, 21,000 plus 27,000, that is going to be 48,000, plus 567 is 48,567, and now 1 million plus 48,567 is 1,048,567. So this is my answer. Alright, so I have 2 to the power of 100 minus 2 to the power of 99. So 2 to the power of 100 we can rewrite as 2 to the power of 99 plus 1 minus 2 to the power of 99. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, for 2 to the power of 99 plus 1, I can rewrite as 2 to the power of 99 times 2 to the power of 1, and then I have minus 2 to the power of 99 at the end. So now, because both these terms have 2 to the power of 99, if I factor out 2 to the power of 99, I get 2 to the power of 99 times 2 to the power of 99 times 2 to the power of 1 divided by 2 to the power of 99 is simply 2 to the power of 1, minus 2 to the power of 99 divided by 2 to the power of 99 is 1. So I have 2 to the power of 99 times 2 to the power of 1 minus 1. Now, 2 to the power of 1 minus 1, well, 2 to the power of 1 is 2, so I have 2 to the power of 99 times 2 minus 1, and 2 minus 1 is simply 1, so I have 2 to the power of 99 times 1. Anything times 1 is itself, so now I have 2 to the power of 99. And 2 to the power of 99, well, this is actually going to be a really big number, because 2 to the power of 10 itself, this is equal to 1024. And 2 to the power of 9, this is equal to half of 1024, which is 512. So every time a new power of 2 comes, it's going to be double of the previous power. So 2 to the power of 11, this would be double of this. 2 to the power of 12, that would be double of 2 to the power of 11, so on and on and on. So 2 to the power of 99, this is going to be a really big number. So that's why this is the most that I can actually simplify 2 to the power of 99. Alright, so in this video, I'm going to be proving to you guys that pi is equal to 3. So as you guys probably already know, pi is an irrational number, meaning it doesn't have a whole number value, and it's actually equal to 3.14159, and on and so forth forever. So that's why it's an irrational number. Its digits don't stop going. So in this video, I'm going to be proving to you guys that pi is actually equal to 3 and not the irrational number that we all know it is. So what I'm first going to do is start with the statement x is equal to pi plus 3 over 2. So all I'm doing is I'm giving a value to a variable, which is completely legal. So now what I'm going to do is multiply both sides by 2. So I get 2 times x is equal to pi plus 3 over 2 times 2. Now, 2 times x is equal to 2x. So I get 2x is equal to, these two 2's cancel out, pi plus 3. So I get 2x is equal to pi plus 3. And now, from here, I'm going to multiply both sides by pi minus 3. So I have pi minus 3 times 2x is equal to pi plus 3 times pi minus 3. Now, pi plus 3 times pi minus 3, I'm going to distribute the pi, so I get pi squared plus 3 pi minus 3 pi, which they just simply cancel out, plus 3 pi minus 3 pi. These two cancel out. And then I have minus 9 at the end. So this is, I can just say this is pi squared minus 9. And for my left-hand side, I can distribute the 2x, so I get 2x pi minus 6x. And now from here, I'm going to add x squared on both sides. So I have x squared plus 2x pi minus 6x is equal to pi squared minus 9 plus x squared. And let me just reorder this real quick. I'm going to write this as x squared minus 6x plus 9. So I'm going to add 9 on both sides. Is equal to x squared minus 2 pi x. So I'm going to subtract 2 pi x on both sides. And at the end, plus pi squared. So I have x squared minus 6x plus 9 is equal to x squared minus 2 pi x plus pi squared. And now, x squared minus 6x plus 9, this factors out into x minus 3 squared. And x squared minus 2 pi x plus pi squared is the same thing as x minus pi squared. So I have x minus 3 squared is equal to x minus pi squared. And now, I want to cancel these two squares, so I'm going to take the square root on both sides. So now the square root of x minus 3 squared is equal to x minus 3. And the square root of x minus pi squared is equal to x minus pi. So I get x minus 3 is equal to x minus pi. So now I'm going to cancel these two x's out by subtracting x on both sides. So now I get negative 3 is equal to negative pi. And now if I multiply both sides by negative 1, I get pi is equal to 3. So there you have it. I just proved that pi is equal to 3. So now where did I go wrong? Because obviously we know that pi is not equal to 3. So where did I go wrong? Well, I actually went wrong on this step right here, where I said that the square root of x minus 3 squared and the square root of x minus pi squared is equal to x minus 3 and x minus pi respectively. Well, this is actually not true. The square root of x minus 3 squared isn't equal to x minus 3, is equal to the absolute value of x minus 3. And same goes with the square root of x minus pi squared. It's not equal to x minus pi, it's equal to the absolute value of x minus pi. So the reason this is so important is because now I get x minus 3 is equal to negative x minus pi. Or also negative x minus 3 is equal to positive x minus pi, since we're taking the absolute value of these two. So if we want to solve x minus 3 is equal to negative x minus pi, we're going to have to first distribute the negative sign. So I get x minus 3 is equal to negative x plus pi. So now if I add x on both sides, these two cancel out. So I get 2x is equal to 3 plus pi. and x is equal to 3 plus pi over 2, which, going back, is what we started with. So there you have it. That is something really important to know, that the absolute value is, the square root of a square isn't just the normal version, it's the absolute value of that.